Yes, class. Mr. McCray again, giving another video, this time on radical square roots, but the harder problems that we're going to be doing in class for math enrichment and also for regular class on Thursday and rest enrichment on Tuesday. Okay, so I made the perfect squares number line again. So the square root, so these are basically perfect. Square roots are basically numbers that can be multiplied by itself. So again, the square root of 0 is multiplied 0 times 0 equals 0. 1 times 1, 2, and I think we know that. So what we've been talking about is the square root and how to simplify these values into its smallest form. So we have the square root of 40. So we did the product property of radicals to do this in prime factorization. We made two things, and then we figured out, okay, what's the highest perfect square we can use to work this number, to simplify this number. So if we look through it, we know 40 is between 36 and 49. Okay, and so that's about 6.3 if we want to approximate that. Okay, now looking at this all the way down, 36, 25, 16, 9, 4 is the only one we can use. So we use the square root of 4 times the square root of 10. Okay, now square root of 4 breaks down to 2. Square root of 10 breaks out to square root 2 over 5. But unfortunately, that doesn't help us break it down. So we're going to leave it the way it is. So our final answer is 2 times the square root of 10. And that's a simplified version of that. That's 1. Okay. Now, we talked a little bit about this in the other video about the harder problems. Okay. So that's how you do the easy ones. Here it becomes harder with the variables in front. Okay, so again, we talked about the product property of radicals. So I can break this out into two separate square roots. 24 square root x squared. Okay, now once I do that, now how do I know what is the value? Let's work with the first one. Okay, so remember we said we want to look to see where it's at. Okay, so it's about 4.9, and then we look for a perfect square that works with it. 24. So 16, 9, no, 4 does. So let me make that a perfect square. Okay, so perfect square of 4 times 6. Okay, so the perfect square of 4 is 2. And the square root of 6, it doesn't break down, so it's just 2 square root 6. Okay, so let me take that out here. Hide that. Just take this out real quick. Okay, so let's do the other side. All right, so again, we know x squared, if we break that down, is x times x. Okay, actually, shoot, I did that wrong. I meant to say it in terms of this way to make it easier for us to see. Okay, we broke this down as two perfect squares out of there, x times x. Okay, and that breaks out just to be x. All right, so we knew that from last time. So again, how would we use this information? Put this together. We have two whole numbers of 2 and x. We're going to put that on the outside, and then we put inside under the radical 6. Okay, and that would be the value. So 2x square root times square root of 6. Okay, so here's some of the harder problems that we're going to be doing today. Okay, now we have a value on the outside, so it's negative 6 times the square root of 100. So whatever we find for the square root of 100, we're going to multiply by 6. That's all it is. So it's negative 6 times what the square root of 100 is. We look on the thing, is perfect square 10 times 10, so that's 10. Okay, so negative 6 times 10 is negative 60. And that's how it works. Okay, just we have a variable on the outside. Now we can work it through. All right. Okay, so let's look at another couple here, and then we'll be done. All right, so here comes a little harder. We have x squared, square root of 200. Okay, so x squared is going to stay on the outside because that's already taken care of. And all we have to do now is break down 200. So we know that this is 100 is a perfect square. 2. Okay, because 200 times 2 is 200. 10, and then we keep the 2 where it's at. Now we got to put it all together. Okay, so it's 10x squared equals square root 10, square root 2. And that would be the answer to that question. Okay, that's how it works. Let's do another one. So 2 is on the outside, that's going to be staying. Now, remember, product property radicals tells us we can split these apart. 36, p to the power of 8. Okay, so again, what's the highest one I can use for this one? Perfect square, we have 36. Actually, This is a perfect square, 36. So wait a minute, change that out. Sorry. So we know that's a perfect square, so it automatically pulls out to be 6. Okay, but what about this one? We have p to the power of 8. T to the power of 8. Okay, so we said before that x squared, square root of x squared equals x. So what about x to the 4th power? Okay, x to the 4th power would be x squared. What about x to the 6th power? Okay, that would be x to the 3rd. Okay, so again, think about it. Now, what would be x to the 4th? Okay, x to the 8th power would be p to the 4th. Okay, because you think about it, all we have to do is write how many p's. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we have 8 p's here. Now, if we break them out into squares of 2's, 1, 2, 3, 4, we'd have 4 of them. So that's what we break out. We have 4 squares of each one. And so that's how it works. Okay? If you want to think about it that way. All right? So a final answer in this one would be 2 times 6 times P4. So that would be 12 P4. And that would be the answer to that. Okay, that would be the simplified version. Okay? Next one, we have an exponent on the outside, -4. That's going to stay. It's going to stay where it's at, and we're going to break down 128. Okay, square root of 128, square root of x to the 4th. Okay, so moving that out again, what we said was x to the 4th equals x squared. So that breaks down into 4 perfect squares. So it comes x to the 2nd. Now this one becomes, okay, think about it here, 64 times 2. Yeah. Square root of 64, square root of 2, 64 equals 8. Make a better 8 there. And then we have square root 2, that stays where it's at, and we have x2. So now we combine that together. 8x squared times the square root of 2. And that would be the answer to those questions. All right? So again, those are the kind of questions that you're going to be doing. You're going to be using a lot of the same rules when we had with the law of exponents. I'm not really talking about them, but you are using them if you really think about it. Okay, I'm not talking about them, but you are using them. All right. So again, this is a short video that we have for hard problems. Again, try the problems out and good luck today.